Hi, folks. Welcome to this new session on how to master the art of consulting in data science. And we will talk about analytical reasoning for data science professionals specifically, right? So, you might be already knowing that the role of a data science consultant is a very critical role and it requires a specific set of skills that one needs to know. No matter how good you are at statistical modeling or programming or whichever coding background that you have already grasped, consultants are some of the most sought after and highest paid individuals. So being a data science consultant is something that you should look up. Being a data science consultant is not like a get rich quick kind of a scheme where you just invest some time, learn up a programming language, or you probably do a couple of projects, apply certain machine learning algorithms, you are aware of certain jargons. It's not that. Being a consultant requires a conscious and step by step effort and also a good grip over the technologies as well as the domain that these techniques are being applied to. So, consulting is a mix of both art and science, and therefore, your own creativity also plays a very important role. Now, in this video, we would discuss some of the basic and most interesting perspectives that each and every consultant needs to be aware of. There is a lot of other skills that a consultant should definitely have, and one of them is being a very good listener. And he or she needs also to master the art of effective communication. So let's dive into this topic and see what are the most important things that you should know if you are a data science consultant or if you aspire to be a consultant in your journey as a data science professional. The first thing is what we call as assumption. The field of statistics, the field of data science is full of assumption. Now, one might ask the question, like, if we are using assumptions and it has no attachment with reality, why do we, always start off with assumptions, right? So one particular reason of starting off with assumptions is that we want to start off with a simplistic structure to begin with, and the model or any kind of deep dive analysis that we do, we try to get into more details as and when we try to progress in that. So a good starting point is an assumption, and that kind of streamlines or creates boundaries of your analysis. For example, if you are not even assuming anything, then your analysis could go in different directions. For example, if you are studying the data for people who are smokers and you are trying to understand if they have a greater chance of having lung cancer, let's say, then you would have certain assumptions at the back of your mind. Because if you start off with a position where you have no assumptions at all, then you are even clueless about what is right and what is wrong. If you have an assumption that you start off with, and over time, when you build a model or do an analysis, this kind of gives you an idea whether the assumption that you started off with, uh, or the informed guess that you started off with, in a way, is being uh, is holding up true at the end of the analysis, right? So, how are assumptions made? So, how to look for assumptions? Assumptions often you use non-definitive keywords. And in keywords, we can have this distinction of definitive versus non-definitive, where definitive keywords use words like all, only, every, and non-definitive words are like maybe, probably, some. So as you can see, there's a difference between the words which are definitive and non-definitive, and this is which can help you understand if you're looking at a statement which is an assumption. For example, if you're looking at a statement which says the sales might drop in case the CEO steps down, the word here might tells you or indicates that this is an assumption. Assumptions can also be indicated by adjectives. An adjective is nothing but it's like something which tries to denote the quality of a subject under consideration. If an adjective is attached to the subject, then we can implicitly assume that there's this characteristic that the subject can. For example, we say the aggressive sales in the last quarter might not be an ongoing trend in the coming quarters. This indicates that we are also talking about the valid assumption that sales in the last quarter was aggressive. Similarly, there's the use of conjunctions, and we often use words like therefore, thus, hence, as. Let's look at this example where we are saying it rained very little this year. Crop yield cannot be good. A valid assumption would be good rainfall is required for crop yield. Now, moving on to what we know as arguments. Arguments can be based on two important. One is premises, which acts as a support, and it could also be based on what is called hidden assumptions, which also act as a support. Now, based on the above two, an argument basically reaches a conclusion. There could be two types of arguments, a strong argument or a weak argument. An argument could be a statement where you are saying the statistical model that we have built should hold good even with new data. The model we are looking at is a long-term model. So this kind of a statement is an argument, right? And if you were to look at the difference between what's a short-term model, what's a long-term model, how do you understand when to calibrate your model? There's a very interesting video that we have uploaded on modeling myopia, which you should look out for in our channel. That can give you some more insights about the difference in modeling techniques and the difference between the two different models. Now, the premise here in this statement that we spoke about is that model is a long-term model. So that's the premise. The hidden assumption is that long-term models should hold good even with new data. And based on these two, we come up with the conclusion that if you're building a long-term model, it's mostly expected not to be modified for new incoming data input. Also, a very important concept for consultants is that of inference or statistical inference. And this basically assumes a very important role in the concept of data science or analytics, and it is something that should be understood in great depth. We'll come up with a video on statistical inference, and you could look up in that particular video about more details about this topic. In very short, what statistical inference tries to tell us is that if you're looking at a very small piece of data and you are trying to come up with a conclusion, a generalized statement about the larger data, which is the population, then you are using statistical inference in some way. So in inference, there are two important concepts that one needs to be aware of. One is that of cause and effect, right? It's like the chicken and the egg problem, right? So which one came first? Is it the egg or the chicken? So what causes what? So there's this direction that is quite important, and this can be summarized in this form. So for example, there's some action that you have taken, and this action causes an effect. Now this can be again thought of in four different scenarios. One is the effect, is there always. So whenever there's an action, there's always an effect. So this kind of gives the notion of strong positive. Now there could also be a scenario where whenever an action is taken, there's never an effect, right? So this again becomes a strong negative. There could also be this scenario where there's some action that has been taken, but only there are some of the times when there has been some effect. This becomes a weak positive instance. And it could also well happen that there has been some action, but the effect is not usually that frequent. So in that case, what we are saying is that this is a weak negative inference. Similarly, we could also have statistical inference in the form of analogy. And what analogy tells us is that we can take examples and use those examples to talk about certain on a new set of examples. So, for example, if you are looking at a set A, and if the set A is equal to the set B, then this implies whatever we have inferred about the set A is also applicable to whatever we could infer from set B. Right? And this kind of gives us an idea about the robustness of a model. So let me explain this in a bit more detail. So robustness of a model is a topic which often a data scientist would encounter, where when you are building a particular model, you generally build a model on training data or training examples, right? And suppose you get a very good fit of your model, and generally there are different ways of looking at how good your model is. And one of the very basic things that people generally look at is known as the R square. And suppose your R square of your model is very high from the training data. Now, you would be overjoyed. So, now, how do you understand whether this model that you have built could be generalizable? How good is your model? So, for that, often what you do is you take another data, which is often called as test data, and you try to run the same model that you have built on this test data and see what is the R square, right? Now, if you see the R square here in this case, and if you find that the fit is good enough, then you are saying that the model is robust. So here you can think of the two sets, A and B, as in a way a train set and a test set. Now, in this particular case, if your test set is exactly equal to your train set, then definitely that doesn't make any sense. But what you can think of in terms of inference is that if your test set contains data that is very much aligned with your train data set, then whatever inference from the model that you have got from the data set A, which is on the training data or training examples, inference that you draw from the next set, which is pretty similar to your train set, could also be logically quite similar. This is the concept of statistical inference, and it's one of the most crucial things that a data science professional generally encounters. And whenever he or she does a model development exercise, this is something that's absolutely critical to understand. One other thing is often while presenting, model results, we generally tend to suggest a solution or a prescription for a particular business challenge that we're solving. Now, two important things, and one of those is something that we have already discussed in the previous slide, is that of the robustness of the model. How do we understand the model we have built is robust or not? Now, there are different ways to, understand that what are out of the there could be multiple alternatives that are good, but out of those multiple alternatives, which is that one solution that you being a consultant should choose? So there could be many approaches to this, and the top two approaches that we can always think about is one is how good or how robust your model is, right? And that can be done by testing your model on different other data sets. One could be a test data set, or you could also do it on a validation. Now, the two are different in some way, and we would not go into the details of this. We will cover the difference more on the topics when we discover about regression, about modeling, and the specific things when we are trying to build and evaluate how the model performance is. We will discuss about these things at that point of time. So watch out for those videos that we'll be coming up with. And for now, what you can understand is that cross validation or validating your model on the validation dataset or on the test data set is a very important step in understanding how robust your model is. So if you have three models, M1, M2, and M3, and these three models are really good models in some way. Uh, to understand which model to select or which model to finally recommend to your customer or client, one step is to understand how good is the model on your validation or your test data set. You could maybe choose one of these three models. Case. Now, also another important factor to consider while recommending is how practical or how feasible is the solution that you are talking. I mean, data is one part and domain knowledge is the another part of doing an entire analysis. So to be a good consultant, it's not always that you need to, be very good with numbers. You need to understand data absolutely, from one end to the other. While all of those things are important, it's also important for you to understand the business very closely. And even if your statistical model turns out a result that seems to be really appealing to business, it might not be a practical or a feasible solution to the business, right? So you could think about, is it practical? Is it feasible? Are there any low cost alternatives? So all of those things should come into consideration before recommending a solution. Now, often it might also be that a given case is not a problem at all. It might just be a way where the client is trying to improve a current situation. So even framing that as a problem or thinking of that as a real life problem is not exactly the way. You could think about improving it in some, right? Now, the cause and effect relationship is one other relationship where we already discussed about the cause and effect relationship at in some detail in the previous slide, where we were saying that there could be four kind of scenarios in a uh, inference. Basically, you take an action and there's an effect of that action. If there is an effect at times or most of the times, then definitely there's a cause and effect kind of a relationship. And this is nothing but a logical and a scientific reason behind the occurrence of. So if you think about a cause and effect, you could think of this as cause could be, you know, uh, the cause could be immediate or it could be principle in nature. So if a cause is immediate, these are things like, for example, if you are looking at advertising and sales. For example, you are advertising your product in the market. You have done a lot of promotion and pricing and promotional activities, and you see an impact on sales. So if, for example, you have done certain promotions out here, right? You can expect the sales to have risen at this point. And again, sales might go up if you have done certain other promotions. Here you have promotions measured over time, and here you could be looking at the sales dollars. So this kind of a relationship is where you are looking at an immediate kind of a cause and effect relationship. On the other hand, you could also look at principal kind of a cause, which is more to deal with things like statistical significance. And we'll cover this term statistical significance in more depth while we are talking about the theory of estimation and how we generally come up with estimates during a regression problem. A very important and useful tool also in consulting is basically what we call as Venn diagrams, and this directly comes from the set theory. So Venn diagrams is an excellent way to represent overlap in data. So for example, you are trying to represent that there are some x's um, which are also y's. So you could represent that in this way, and often it's a very useful and handy way of representing data in the form of visual. You are saying that this particular is a set which is x, and it has certain data, certain observations. 1 x2 2. And this could be one particular set you are looking at, and this is y, where this is your set y, and you would also have data on y1 up to n. So if you say that some x's are also y's, which is denoted by this shaded region, you could represent it. You could represent this in the form of Venn diagram, or you could also, represent this in a different way. You could also think of this like maybe x is here and this entire thing is y, or you could also think about reversing this. You could have y here and you could have x here. Similarly, if you were trying to show a data or you were talking about a data where you are looking at all of the x's which are y's, right? So here you could represent this in this form, correct? And if you were to show that no x's are y's, then you could show this in this particular way. These are disjoint. So as you can see, Venn diagrams is absolutely a very useful way to represent different cuts and slices of data and visually understand where there is overlap in the data and where there is not. A very important application of Venn diagrams is also in place of confusion matrix, and in very short, we will talk about confusion matrix when we are talking about classification models specifically. And confusion matrix is one important tool for us to understand what is the rate of misclassification in a particular model. Just to give you a brief idea about what the topic is all about, what is confusion matrix and what is classification. So in classification, what we try to generally do is we have a certain number of training data or certain examples, and we try to classify them into groups. So there could be group 1, there could be group 2, and we could have different n number of such groups. And we have all of the data out. The entire task is to correctly classify these data points to the correct group. Now, this is a part of a supervised problem. And what we mean by that is, you have each data point out here, D1, attached to a specific group, G1. You could have D2 assigned to group 1. And similarly, you could have, you know, D3 also assigned to group 1. Similarly, so G1 becomes a label for these data points. Similarly, you could have maybe D4, D5 attached to another group or a label group 2. Imagine these are certain images, let's say, and group 1 is that of a cat, this is of a dog. So based on images, you need to classify them as which of the images are of cats, which are the images of dogs. Now, what confusion matrix tries to do is it tries to show you that, what are the number of basically, okay, so here, if we say that this is a number, so what is the number of, images that you have been able to correctly classify? And by correct classification, let's say we are looking at actuals on this side, and we are looking at predicted, or what comes out of our model, what comes out of our analysis on this side. So here, let's say this is a correct classification of either a cat or a dog, and this is a wrong classification. Similarly, suppose this is a you are predicting it in the correct way, or you can think of this as true also, this in the wrong way. This is false. So now you measure or you look at how many number of cases are there which in reality are correct and which your model also have predicted to be correct, which is this. Similarly, you can also look at how many are correct in reality, but your model has shown to be incorrect. Similarly, you can look at this particular cell, and this shows you that in reality how many are not a particular category, maybe not a cat or not a dog, but you have classified it to be a cat or a dog, vice versa. And the last case is where both your actual and both your model, they tell again the same thing. right? So this kind of gives you an idea about a confusion matrix and kind of looks at, what is the misclassification? How many cases do you end up with from your model where you are not able to classify things in the right way? Right? And this also talks about data and overlap. If you think about it logically, we could represent this entire confusion matrix, the logic of it, in the way of Venn diagrams to make it very easy. So imagine that you are starting off with an entire set of x variables and y variables, where x's are your training examples, the ones that we saw here. You could think of them as the images that we are looking at, and Y's could be the labels or the groups. You start off with all of those examples, and then gradually, once you build your model on this data, each of these four boxes, now you can look at each of them as either X overlapping Y, or Y X over here, and you could create all those combinations out. So that makes Venn diagrams a very useful tool and has wide area of application, especially if you're looking at confusion matrix or anywhere where there's an overlap of data. One other important topic is basically where we also look at what if scenarios or goal six scenarios. So and why this is important is, you know many a times what happens is that you build a model and you generate certain results, and I mean, what could happen is that client or the customer who is in the business might want to understand that if your results vary a bit, or if they want to move away from whatever you are recommending, how much does something change? How much does, the key performance indicators or the key goals that a business has, how much does those change? So this is more like, you could have two important concepts here. One is that of a what if scenario, where suppose, it helps us see how our target variable value changes based on different scenarios. So imagine that your target variable here is the dollar sales the business is looking at, and what you have done is you have recommended the business a solution where you are saying that, folks, increase your marketing spend on television by $1,000, correct? In order to achieve the target dollars that you are looking at, or in order to achieve the maximum benefit. Now, the client might come back and ask you that, okay, based on your suggestion, we will go ahead with $1,000 of TV. But we just wanted to run a few scenarios where we wanted to understand what happens if we increased our TV marketing expenditure by maybe $1,500 instead of $1,000. How would that really affect our sales dollars? Or it could also be a situation where, I just want to understand what happens if I increase my TV marketing expenditure by $800, and maybe increase my radio expenditure by another $200, and see how does that interact and how does that translate in sales dollars. So these kind of scenarios are very useful for businesses, and as a consultant, you should always be ready with such what if scenarios and such results, right? In order to be able to help with quick information to showcase to your clients, tell them that, this is based on this is the recommendation provided based on running a lot of what if scenarios, and that kind of gives a lot of confidence to the business people. Even goal seek is another way, and this is probably, if you're trying to look at the flip side of the what if scenario, you would end up in a goal seek scenario, where in this particular case, there's a target value for a target variable defined, and your algorithm or model that you're building tries to calculate what are the best possible values of those input variables that can help us achieve this particular target value. If you look at the same example out here, imagine that your client has asked you that, let's look at target dollar value of uh, maybe $500 million. and your client wants to achieve this $500 million. And from the business knowledge, you know that sales dollars is a function of lot of variables, be x1 up to xn. And this could be variables like weather, it could be variables like the holiday season, it could be variable like what is the spend on different media, the promotional activities, all of those things are you have all of these factors and data around all of them. So, and you also have a budget, right, for all of these marketing tactics. Now, the client asks you that I need to achieve $500 million in sales for the next quarter or the next year. That is a goal seek problem where you try to find out what could be the optimal values of these X's, you know, such that your goal is achieved, goal of $500 million. That makes what if scenarios and goal seek an indispensable tool to be used by data science practitioners, especially consultants. And this gives a lot of visibility, guys, to the clients. If you're trying to solve a client problem, and if you're handling client questions, and if you're handling them, they would be essentially looking for things. So we discussed about a few important tools and techniques, and I hope definitely this was useful and will be able to make you better as a data consultant. And hope this was helpful. So that's all that we had to discuss for the today's session, and hope you have learned something new. If you're looking for any kind of a private mentorship, career counseling, or even if you want to practice mock interviews, to be well prepared in your data science interviews that are upcoming. And even if you're looking for any kind of guidance on data science, specifically if you're a complete beginner, you know, this is the right place. All you need to do is you need to fill up the form that is provided in the description section of the video below, and one of our support team members will get in touch with you. We are a group of industry professionals who try to help each other in their journey to practice data science, to begin data science as a career option. And this will be a good exercise for you to look at the videos. So most importantly, do not forget to click on the bell icon and press the subscribe button to stay updated about any of our new and interesting videos that we keep uploading. That's very important, so please do not forget. Thanks for watching, stay tuned, and we will come up with our next video pretty soon. Thanks for watching.